Now let's talk about universal logic gate. This is very interesting topic. So we have NOT gate. Okay. Now NOT I can implement with using a NAND. Okay. So if I connect one of this input of the NAND gate as 1, then its output become X bar. By identity you can prove it. 1 or X whole bar is X bar, right? 1 or X is, sorry, not 1 or, 1 and X whole bar for the NAND gate, 1 and X whole bar, that is the NAND operation, and 1 and X is nothing but X. So it's become X bar. Similarly for the NOR, if you connect one terminal to logic 0 and supply a Boolean value X, which can be 0 or 1, then we'll observe an inversion of that logic or a NOT operation through this NOR gate. You can well imagine it is 0 or X whole bar, and then 0 or X is basically X by identity, and that becomes X bar in logic. So that means I can implement inversion gate or NOT gate using either NAND or NOR. How about NOR? NOR is a function, is a X or Y whole bar, okay, which is by De Morgan, it is X bar and Y bar, okay, X bar and Y bar, right? So if it is X bar and Y bar, then X bar I can compute it by a NOT gate, like NAND based NOT, X bar, we NAND it, X bar and X bar NAND Y bar, and then we are inverting it, right? So internally this X bar and Y bar whole bar, it is basically by De Morgan is X or Y whole bar. So using this 4 NAND gate, like 3 of them used as an inverter and other is a NAND gate, we can implement a NOR. How about other way? We have a NAND gate, can I implement using it NOR only, right? We can, again by De Morgan, your XY whole bar, where XY is nothing but X bar or Y bar whole bar, which is by De Morgan, like we can expand that, and each of this X bar, Y bar, we make an inversion gate with NOR, that we can do, like we have seen that earlier. And then we pass it to the NOR, and then we invert the output, one more inverter. So using 4 NOR gate, I can implement a NAND gate. So essentially you are seeing that if I have only NAND gate, I can implement NOR, I can implement inversion, and therefore I can implement any logic in the whole world. On the other hand, if I just have a NOR gate, then also it's true. I can implement an inverter gate with a NOR gate. I can implement a NAND gate with a NOR gate. So that means if I have only NOR type of gate, then I can also implement any logic in the whole world. So that's why NAND and NOR are called universal logic gate, because you just need only one electronic component, one type of electronic component, either NAND or NOR, to implement any Boolean function, whatever human can think. So that's a universal logic gate. So that's all for this lecture 15. If you have any question, please send me an email or let me know in the class.